Welcome to SIS 220 System Level Programming. I'm Dr. Burton Ma. My office is in Goodwin Hall, room 754, so that's on the 7th floor of Goodwin. When you exit the elevator, turn left, go through the double doors, and turn right, and my office will be in the hallway that you're in. My office hours are in person in my office. Hours will be announced and published on OnQ, so on the SIS 220 OnQ. Those will be published later this week. If you want to contact me outside of office hours, then the easiest way to do so is through email. Please don't try to message me on Teams or through email, or through OnQ. I probably won't see those messages. So when you send me email, please include SIS220 in the subject line so that I know what course you're in and I can deal with your email appropriately. I teach something like 500 students each term, well, roughly 500 anyway. And so if you don't include your course information, it's very awkward or inconvenient for me to look up which class you're actually in so that I can deal with your email. Teaching assistants, I don't remember how many there are. They will have 1 hour each of online office hours where you can contact them on Teams. My office hours are in person. So you have to drop by Goodwin 754 if you want to talk to me. Everything about the course will be on OnQ, either now or as it's being created. All the lectures are recorded. They will be posted to OnQ, but it normally takes, sometimes I'm good and it actually goes up the same day it's recorded. It's not unusual for it to be several days later before the video goes up. There's a YouTube playlist. You can subscribe to the playlist if you want to get automatic updates about when videos go up. That's on OnQ. I think the link on OnQ right now is the wrong link. It's the link to the previous term. So I'll update that link after class. Okay, textbooks. There is no textbook for the course. I use Jupyter Notebooks for everything, so all of the course material is available either as PowerPoint slides, source code, or as Jupyter Notebooks. So I'll show you that in a second. If you took 124 with me, you know about these things already. If you haven't, I'll show them to you in a minute. There are a set of online notes available from the library written by Dr. David Lamb. They're very terse, so there's not a lot of explanation in those notes. You can refer to them if you want to. The information there is certainly valid. I think you'll get more utility out of the notebooks and out of the lectures. If you want a textbook or a reference book of some kind, there's a bazillion resources on the web. The library has excellent online books that you can access for free, as long as you have an internet connection. The Linux Command Line, 2nd edition, that's a pretty good book for this course. It's a pretty good reference book for this course, at least for the half of this course. The other half of the course, you want a C textbook, so Effective C is a pretty good C textbook. There's lots of books for Bash and for C. Grading. I guess we might as well just jump to OnQ. Okay, so this is OnQ for the course. If you go to Content, lecture slides are here. They're all up for the term. You can find them there. Previous exams are here with answers. You'll notice here there's an exam appendix and a cover page. You do get some information for the exam. You can look at that link there if you want to see what information you get for the exam. The quizzes, so there are 2 quizzes for the course. I'll explain that in a second. Last term's quizzes are here, so you can see them and their answers. When the assignment solutions, after your assignments are due, I post the solutions to all assignments, they'll go there. So under the course description, if you click that, you get the normal calendar description of the course. The grading scheme is here, so this is the part you're probably most interested in. Assignment 1 is worth 5%. That basically makes sure you have your computer set up to actually do this course, or you have access to a computer where you can do the work in this course. So it's worth 5%. There's another 5 assignments after that, each worth 8. There's 2 tests in class. Those are the 2 dates for the 2 tests. So those, you can consider them to be firm. So you can schedule around those if you have to. And then finally, there is an exam scheduled by the exams office. And they'll set that date, I guess, sometime in March. Probably? February, March. They'll have those dates set for you. What about the quiz test? So, okay, so if you, let me go back to my lecture slides. Okay, so the assignments, you're supposed to do them individually. You submit them on OnCue. There is a universal accommodation policy in place for this course. So everybody, no questions asked. There's a due date, and then 3 days after the due date is when the assignment stops. You can hand in anything up to, from the due date up to the 3 days after without penalty. You don't contact me or the TAs about it, you just hand it in and don't worry about it. Okay? So after 3 days, the assignment's not accepted. Unless you're one of these students with academic accommodation, and it's one of those 7-day or up to 7-day accommodations, you have to contact me ahead of time and tell me that you need to use this for some reason, and then we'll try to do something about it. I may say no, especially for assignment 2 or 3. There's whatever assignment is before the test. I try to make sure that you get the assignment solution before the test. So if you need a 7-day accommodation for that particular assignment, I'm probably going to say no to you. So just keep that in mind, right? So I need to be able to publish the solutions for the assignments so that people can study off the assignment solutions. Right? But again, everybody, 3 days after the assignment due date, don't email me, tell me it's going to be late. I don't want to hear about it, right? Just hand it in. Everything will be fine. Right? Quizzes. So the quizzes are written in class, so probably in here. They're 50 minutes long, so you finish them in class, and then, well, that's it for the quiz, right? It's just a standard quiz. You can see the last term's quizzes on OnCue right now, right? And again, the exam is in person, it's written, that's scheduled by the exams office. Okay, so any questions about the course administration? Super. So what is this course about? So this is called system level programming. I guess the best way to describe this is most of us, when we use our computers, right, we're using some sort of graphical user application, like PowerPoint, right? Or maybe you're programming and you're using your favorite IDE. So Eclipse, Visual Studio, something like that, right? But the way you're interacting with the computer is via a graphical user interface, right? This course, we're going to work at a lower level. So you're going to be using something called a terminal. Looks like this, which doesn't look like anything, right? You can type into this thing, and that's all you can do, right? And so this is a terminal that's running, this is a Linux terminal. It's running something called bash as its shell, right? And this thing basically sits here waiting for you to type in commands, and it responds to the commands, right? And so this is this is one of the earlier ways that were developed for interacting with the computer system before we had all of these graphics, right? Before you had a mouse and other things like that, right? All you had was a keyboard and a terminal like this. And so you're going to be interacting with an operating system via a terminal in this course. Right. Along the way, you're going to be learning about these things called shells and a scripting language that goes along with the shell. So there's a programming language that goes along with the shell. You'll learn about programming in this language called C. Right? And of course, there's also some more software development stuff as we go along. In a nutshell, you're going to be learning about an operating system called Linux, or for our purposes, it's just it's more or less Unix, right? You're going to be using the bash shell to interact with Linux, and then you're going to be programming in C, right? Also in Linux. Okay, so where is it? Okay. So one of the main purposes of this course is to set you up for your architecture course and for your operating systems course. Right? And so SIS 324, the operating systems course, which most of you have to take, tells you about operating systems. Right? So an operating system is just software. Right? For you on Mac, it's a Mac OS. Right? If you're on Windows, it's Windows OS. Right? If you're on Linux, it's whatever flavor of Linux you happen to be using. Right? So your operating system is the thing that sits between, so it's that thing there, it sits between your computer hardware and the rest of your, other computer software, right? And so when you're running something like PowerPoint, when you save a file from PowerPoint, right, the saving of the file goes through the operating system, right? And the operating system talks to the hardware to save the contents of your file to the hard disk on your computer, right? Or if you're using cloud-based services, it has to talk to your network driver so that it can send stuff out onto the cloud and save stuff on the cloud, right? The user who sits up here, normally you interact with just a regular application, again, like PowerPoint or something like that, right? As a user in this course, you're also going to be interacting with the operating system itself. Right, so SIS 324 is all about operating systems here. We only talk a little bit about it in this course. Whoops. Okay, so I talked about the issue between a graphical user interface and a command line interface. Right, all of us are probably used to a graphical user interface. Right, I'm going to show you in a few minutes what it looks like to use a command line interface. Right, so almost, well, certainly the first half of this course, you're going to be using a command line interface to interact with an operating system. Right. The operating system we're using is something called GNU Linux. Right, if you want to click on that link, you can find out a little bit about what Linux is. Right, but in brief, Linux is a free, so anybody can use it for no cost. Right, open source, anybody can see the source code for it. Operating system. It's widely used in the world today. It's not widely used, so the average person probably doesn't use Linux directly. Where it is used very widely is stuff where the average person isn't really interacting with it. Right? So servers, mainframes, supercomputers, embedded devices. Right? Those are all things that an ordinary user isn't interacting with directly. Right? You interact with servers indirectly. Right? You watch Netflix, you're getting your video off a server somewhere. Right? You go to the bank, your bank's probably got a mainframe kicking around somewhere where your accounts are managed. Right? Supercomputers, most of us probably don't use with any regularity. Embedded devices, you interact with these all the time. Right? These are things that don't look like computers, but they actually are computers inside. Right? That clock, for example, up there is an embedded device. It probably has a little computer in it. You don't interact with it in any meaningful way, but there is a computer in there. Right? It's running it may be running an operating system of some kind. It might be Linux. Right? Most people just call the operating system Linux instead of saying GNU Linux all the time. Right? Now, if we're going to be using Linux, you need to have Linux set up on your computers. Or you have to do all your work in CASLab. It's up to you how you do this. Right? So you have access to CASLab. You can go get yourself an account. That gives you access to the CASLab computers. All of the CASLab computers are bootable into Linux. Right, so if you don't have yourself a CASLab account and you want one, go ahead and click that link there and you can go get yourself a CASLab account. I think it's true that most students don't set up a CASLab account for this course. They use their own home computers. If you have a Mac, you're basically good to go. There is some setup that you have to do, but not very much. Right? Mac OS is a Unix-like operating system. So it's, for the most part, it's suitable for the purpose for this course. Microsoft Windows, you can now, assuming you're not running a very old computer and you are running Windows 10 or higher, you can set up Linux inside Windows using the Linux subsystem for Windows. Instructions are on OnQ. So if you go to course readings and resources, right? If you're a Windows user, click that link. If you're a Mac user, click that link. Both links will set your computer up so that you have all the software that you need. If you want the course notebooks, which I'll show you in a minute, they also show you how to set up the course notebooks on your computers. Right? And so you can access the course notebooks without needing a network connection. You don't have to set the notebooks up on your computer. If you go to the lectures page, if you go to the lectures page, at the top of the lectures page, there's a link. Right? This takes you to the online version of the notebooks. The problem with this link here is that the online version of the notebooks, they're not guaranteed to be available all the time. Right? So number one, you need a network connection. Number two, whatever server happens to be running this notebook needs to be up and running. It's not a server that Queens manages. Right? So this is some server out in the world somewhere that someone is giving us for free to host the notebooks. Right? So I would encourage you to install the software that you need to run the notebooks on your home computers. That way you're not stuck the day before the exam when the notebook goes down, you don't have anything to study from. Right? The instructions on OnQ tell you how to do all of that. Right? So if you go to, excuse me, for example, the Windows one, You install some software, and then you click that link there, and there's a set of instructions here that tells you how to set up the notebooks in Windows. And the same, there's a similar set of instructions for Mac. Right, so if you're running Linux, then you're good to go, right? So if you happen to be running Linux on your home computer, everything's fine. So it is possible to set up your computer for this course and not have to go into CastLab to do your work. Right. Having said that, you can always go to CastLab to do your work.
Like in SIS 124, there are a set of Jupyter notebooks that have been written for this course. So the Jupyter notebooks in this course, they run Bash and C inside the notebooks. So if you've got the notebooks installed on your computer, you can follow the instructions on OnCue to start up the notebooks. If you're in Windows, you're going to want to start up your Linux subsystem and then start up Jupyter from your Linux subsystem. If you're on a Mac, you just open up a terminal and start up Jupyter from in that terminal, following the instructions on OnCue. I'm looking at the online version of the notes, which are exactly the same as the version of the notes that you might install on your computer. When you click on the file start here, .ipynb, you'll open up the table of contents page. So you can see here that there are some links to reference material for the course. So the Bash manual is here. A C library reference is there. And these are links to books in the library, online books in the library that you can access if you want additional references. If you scroll through the table of contents, you can see that the notes are broken up into Bash and C. I think this says currently incomplete. I think they are complete now. So at some point I should update this notebook. But I believe that these notes are now complete. We're going to start with Bash in the course. So I'm going to start by opening up the Introduction to the Command Line notebook, which will take you to here.
Right. So when you open up this notebook, you end up on this page here. Anything that's in gray is a code cell. You can run the code cells on your computer. The crazy thing about all of this is that this code cell here is a Bash code cell. So it's the programming language that the shell uses, which is running in Linux, which I'm showing on a Windows web browser. And the shocking thing about this is that it actually works. Right, so when I run this cell, either by going to cell run or pressing Control Enter, it will actually run this Bash command. Right, and so it prints out hello world, which isn't that surprising. So the command echo is the Bash command that prints a string. Right, so I can go into, so this is a Bash, oops, sorry, come back. All right, so this is a Bash terminal. So if you're using the Windows subsystem for Linux, when you start up your Linux distribution, this is what you see, right? All you get is this black screen, and you can type stuff in it. If you're on Mac, you're going to open up your terminal program. You're going to see something similar. You get a little window. You type into the window, and that's how you interact with it. Right? And so what the shell does is it sits here. It listens for the user to type in commands, and then it waits for the user to press Enter. Right? So if I type in that command that I just typed in, which was echo, and then hello world, like that. Right? When you press Enter, the shell interprets what you typed in. Right? So it looks at that and it says, okay, so what's the user try to do? Right? It looks like they're using the echo program, and they're passing in the string hello world to the echo program or command. Right? And so the shell runs the echo command, passes echo hello world. All echo does is it prints a string, right? Which is why it's called echo. Right? So it prints out the string hello world. You can print out whatever string you want, right? So ABC, that works, right? ABC 1, 2, 3, that also works, right? If you want a string, you can put it in single quotes or double quotes. That all works, right? So echo is one of the commands that echoes a string or prints a string to the terminal. Right? Okay, so this terminal is running in some directory or some folder on my Linux subsystem right now. Right? So the command pwd is the command that tells you which folder or which directory is the shell currently running in. Right? And so it tells you that the shell is currently running in that folder right there. Right? So there's a folder called slash, right? Then there's a folder called home. Right? Inside that folder, there's another folder called Burton. Inside that folder, there's another folder called 2023F. sys220, and then sys220 current main, and then bash. Right? So that's the current folder. More properly, it's the current directory that I'm in. Right? I'm calling it folder because most of you, when you use your operating system, you're used to either Windows Manager or, I forget what Mac calls it, Finder. Right? And that's all graphical user interface. It uses the folder analogy. Right? But these are all directories. Right? Inside this directory, there's a bunch of files. Right? If you're on Windows or Mac, you would open up Finder or Windows the File Manager, and you would get a graphical display of the files there. Right? From the command line, you don't get that. Right? If I want to know what's in the folder or in the directory, right, I use the command ls, right, which is short for list. Right? That's the ls. It's not one s. Right? And if I press ls and I press enter, it lists all the files that are in the folder. Right? All of these files that end with IPYNB, these are your notebook. These are your Jupyter Notebook files. Right? Right? On my computer, anything that's in blue, that happens to be another directory or another folder. Right? So there's a folder of images that contains the images that are used in the Jupyter Notebooks. Right? There's a directory called scripts that contains many or all of the scripts that are used inside the Jupyter Notebook files. Right? So that's the ls command. Right? Oh, if I run it from here, it gives me the exact same output. Right? I happen to know that. So I happen to know that this notebook is running in this directory that I'm also in the terminal. Right? So both the terminal and the notebook, they happen to be running in the same directory. Okay, so in my directory, there's a bunch of files. Right? One of the things that you want to do when you have files is you want to know what's in the file. Right? So for example, I might want to know what's in this file, animals.txt. Right? If you're in Windows or Mac, you double click on it and then some editor pops up and it shows you the contents. Right? From the command line, you don't really have that luxury. Right? Instead, you output the contents of the file. One way to do it is with a command called cat. Right, which is short for concatenate. Right? So cat followed by a file name prints the contents of the file to the terminal. Right? So again, I can run it from the notebook, right? And you see it's just a list of animal names. Right? So cat, zebra, dog, armadillo. You can do the exact same thing over here. Right? So you type in cat and then animals.txt. Right? The shell runs the cat command. It passes the file name animals.txt to the cat program. Right? Cat prints the contents of the file. Right? There's another file called fruits, I think. So I remember there is a bug in this notebook. There should be an S there. Right? So there's a file called fruits. You can list the contents of that, right, by using cat. Right? And that prints out strawberry, mango, pineapple, and apple. Right? Cat doesn't just print out one file. It can print out the contents of as many files as you want. Right? So I can cat animals.txt and fruits.txt, and it prints the contents of animals.txt, followed by the contents of fruits.txt. Right? So once again, cat, animals, fruits, right? And you get the animals, followed by the fruits. Right? If you reverse the order, right, you get the fruits, followed by the animals. Right? So a command, many of the commands in bash, they accept one or more arguments. Right? So one or more arguments. Right? In this case, cat will accept one or more file names. Right? And it will output the contents of each file. Right? So what you're going to learn very quickly in that because all you have is a command line interface, right? And this was especially true back in the earlier days of computing when all we had was text, right? Most of the commands that we're going to be using are all text-based, right? So if you've got a file that consists of text like animals.txt, right? often you want to process the file somehow, right? So for example, you might want to sort the contents of the file, right? So sort animals.txt reads the file animals.txt line by line, and then sorts the output, and then prints the sorted output, prints the sorted file to the output, right? So it reads each line of animals.txt, right? Each line is considered a separate line, right? It then sorts the lines, in this case in alphabetic order, and then prints them out after doing the sorting, right? So now we have the animals in sorted order. Right? Sort will accept more than one file as well, right? So sort animals.txt and then fruits.txt, right? It sorts them all, right? So it takes the contents of animals.txt and the contents of fruits.txt, right? And then sorts them in alphabetic order, right? So here you've got a fruit, and down here you've got an animal, and in between you've got a mix of fruits and animals, all in alphabetic order. Okay. Now, one of the things you're going to be doing in this course is that you're going to want to solve some sort of programming problem, and you've got a bunch of these little commands that you're going to be using, and you'll realize that this command solves one part of the problem, right? I have a different command that solves another part of the problem. Wouldn't it be nice if I could take the output of one command and send it to another command, right? So here's an example of doing exactly that, right? I'm going to use cat to list the contents of animals.txt and fruits.txt, right? I'm then going to send the output of that command using a vertical bar, to the program sort, right? So what this does is the following. So animals and fruits, right? So that prints out the animals, then the fruits, right? I can take that output and redirect that output to another command, like sort, right? Sort is now going to take this output, right, and sort it line by line, right? And so now you end up with the sorted output, right? So that is a second way of sorting the contents of two separate files, right? There's more than one way to do things, right? I can just use sort on its own and pass it the two files that I want, right? Or I can use another program to print the contents of the files and then pass that output to sort, right? And so another thing you're going to realize is that there are many different ways of solving the same problem. Okay, so there's another little command called grep, right? So again, everything that we're going to be working on in this course is text-based, right? And so if you're working with a lot of text-based files, it's often the case you want to search for a phrase or a string or a sentence or something like that in your files, right? And so the grep command is one of those commands that will do that, right? So grep searches a file or files for a pattern that you specify. The pattern is called a regular expression, and we'll talk about that in like 3 or 4 weeks. Right? So for example, if I want to find all the animals that start with the letter A, right, you can use the command grep to do that. Right? So the command is grep. This funny $A means find all of the look for all lines that start with the letter A, right, in the file animals.txt. So you run that, right, and it tells you there's exactly one line that starts with the letter A, and that's armadillo. Right? If you just say grep A, animals.txt, that searches for all the lines that contain an A, right? And so now you've got cat, zebra, and armadillo, right? If you say $A, that finds all the animals that end with an A. Right? And so later on in the course, we'll look at grep in more detail, right? And regular expressions in more detail. But grep is a super handy program when you're dealing with text-based data. Right? There's another example. This searches for all of the lines in the fruits file that have a P in it. Right? Again, if you want to find the fruits that start with a P, it's just $P. Right? If you want to find the fruits that end with a P, it's $P$. And there will be none. right? So sometimes commands produce no output. All right. The date command. So again, remember, so you're on a computer, right? All you've got is this terminal, right? So all you're staring at is this black screen here, right? Often you want to know what time is it, right? On a modern computer, you just look in the bottom right-hand corner, right? Or the upper left or something, right? But if you're just looking at a terminal, you need a command to get the time. So that's date, right? Date tells you the time, right? So it's Monday, January 8th, and it's currently 10:42 Eastern time. It's not 10:42. So something's gone wrong with my computer. It's definitely not 10:42. Right. Okay. So what I haven't shown you yet is that you can modify the way that a command behaves. Right? And the way that you modify the way a command behaves is you pass it some options. Right? So date, if you're not using Mac, date has this option. I'm going to explain that in just a second. So if you're actually on a Linux machine, right, and you write that, right, that gives you just the date, right? It doesn't give you the time, right? So minus big I date tells you the current date in some nice format. Okay, so I just said that if you're on a Mac, you may not have this format. So Mac, you have to be a little bit careful if you're using a Mac. So the commands on Mac are not, some of the commands differ than the ones that I show you in the course, right? So Mac OS is not Linux, right? The commands that it has, that it defaults to are not necessarily the same as the Linux commands that I run on this machine, right? And so you have to be a little bit careful with some of them. So date is one of those commands. Right? Cal is the command that prints a calendar, right? So if you type in cal, that gives you a calendar that prints out the current month in calendar format, right? If you want a different month, you can ask cal for a different month, right? So minus M1 gives you January. Minus M2 gives you February, right? And minus M12, of course, gives you December, not surprisingly, right? So again, I can modify the output of a program or a command by passing in options to the command, right? If you want the entire year, you can write cal minus y, and that gives you, well, it doesn't look so great here, hang on. That gives you the calendar for the entire year, right? All 12 months. Okay, so one of the things that you're going to have to get used to is that you're going to have to learn what are the various options to all of these commands, right? Somewhere at the top of this page, I think I didn't show it to you. Hello, where's my, oh. Okay, so on my computer, if you asked for the number of commands that are installed on this particular, in Linux on this particular computer, there's over 4,000 of them, right? No one's expecting you to learn all 4,000 commands for this course, right? There's probably only a dozen or so that you need to know in this course. Somewhere around a dozen or 2 dozen, right? The problem is all of these commands also have a bunch of options, right? And so you need some way to, one, learn what the options are, right? And then you have to learn how to use the options to do what you want to do. Right, and so as we go on through the course, I'm going to show you how to use these options. I'm also going to show you how to find out information about these commands, right? Because nobody, well, I shouldn't say nobody, most people don't remember all of the commands and all of the options that are associated with it, right? You have to look them up when you need them. There is a way to do that. There's multiple ways to do that, right? But, okay, so now just some stupid stuff. So there's a command called fortune that may or may not be installed on your computer. Fortune just prints out a random saying, right? So every time you run this, it's going to give you something different, right? This one, sometimes the sayings are humorous, sometimes they are meaningful, sometimes they're rude. I don't remember if I have that installed on here or not, right? But every time you run this, you'll get a different one, right? And so one more time, right? Oh, this time you get a quote from William Shakespeare. The CalSay program, that's a program that prints out something using a cow, right? So CalSay, hello. right? And so that prints out the string hello using a cow, right? You can change the animal that's printed here, right? There's like Hello Kitty and a bunch of other things. It's dinosaurs and a whole bunch of other things, right? These are all just silly little programs. They're silly, but they do illustrate a point, right? They're all commands, right? Everything that you do from the command line goes through a command of some kind, right? All commands work the same way, right? They have options, they have inputs, they have outputs, right? I can take fortune, right? So I get some random saying. I can take that output and I can pass it to cow say, and that'll use a cow to print out the fortune. So there you go, right? Oh, yes, we're starting to get slightly rude. I haven't gotten in trouble yet. Someday I'm going to get in trouble for what it prints out. But anyway, that hasn't happened yet. All right, and so there's a bunch of other silly commands that you can run, right? There's the matrix. I guess that movie's kind of old now, so that may not be meaningful for most of you, right? There's a command called, it looks like toilet, right? But it prints things out in a big banner, right? And a bunch of other commands that you can, oh, I think it's installed on here. Steam locomotive, prints a locomotive, right? So there we go. So SL, so notice the command is SL, right? One of the most common commands that you use on your computer when you're working directly from the command line is ls, right? You need to know what's in this directory, right? So some programmer somewhere with too much free time on their hands, right, realized that they typed in SL mistakenly all the time. Wouldn't it be funny if that printed out train instead, steam locomotive? Someone spent who knows how many hours doing that, right? The fact that you can get this to show up on a terminal is pretty amazing, right? And so on and so on and so on, right? So as we go through the course, at least for the first 5 or 6 weeks or so, it's all about using commands in Bash, right? So everything that I'm going to be doing is either going to be through a terminal here or through a Jupyter notebook, right? You can run them either in the notebook or in the terminal directly, right? All right, I guess that's enough for today. We'll pick this up in the next lecture. Oh, in the meantime, get your computer set up so that you actually have a Linux-like environment on your computer and the course software installed.